So in today's video, we will continue discussing some problems regarding SSP. Okay. So today our first question: the value of theta at which the first order peak in X-ray lambda is given 1.53 Armstrong, diffraction corresponding to 111 plane of a simple cubic structure. Today's video and today's questions which I am going to discuss are helpful for JAM, JEST, GATE, NET examination, BARC, TIFR. Specifically, I will tell you that which question is more important. Like this question is important for all type of exams, all sort of exams. The level of this question is like important for all exams. And I will suggest you another thing, that you make two copies regarding a single topic. Make a theory copy and make a sums copy. Okay. So structure with the lattice constant A equals to 2.65 Armstrong is approximately options: option A 15 Armstrong, option B 30 Armstrong, option C 45 Armstrong, and option D 60 Armstrong. So right now you pause the video, try yourself, okay, and then you can check the solution. See the question: the value of theta at which the first order peak in X-ray lambda is given, diffraction corresponding to plane is given of a simple cubic structure with the lattice constant values given is approximately. So you have to need to find the value of theta. So what are the given values? Lambda is given, HKL value is given, structure is simple cubic, and E, that is the lattice parameter, is given. So first we can find the interplanar distance D. For simple cubic structure, the mathematical formula of interplanar distance D is what? A by root H square plus K square plus L square. Okay. These values are different for SC structure, orthorhombic structure, tetragonal structure, trigonal structure, and the mathematical formula regarding this I have already discussed in a lecture, and the name of the lecture is SSP Short Formula Notes. Link of that I have given in the description box. So please kindly go and check there, you will get the formulas. Okay, so for SC structure, the value of the interplanar distance D is this. And another thing which we need to know is Bragg's law, which we are going to use here. This is what? 2d sine theta is equals to n lambda. Okay. Okay. So here n is what? The order of diffraction. Here first order diffraction, so the value of n is what? 1. So you substitute 2 into a by root h square plus k square plus l square sine theta, that is equals to a value of n is 1 lambda. So sine theta equals to lambda root h square plus k square plus l square by 2a. Now we will substitute the values which is given. For lambda it is given 1.53, and these are all 1, and lattice parameter is given as 2.65 Armstrong. This is also in Armstrong, this is also in Armstrong, so we don't need to change any units. Okay, so we are getting what? 1.53 by 2 into 2.65, and this is root 3. Now root 3 is what we know, 1.732, right? We need to calculate this. 1.732 by 2 into 2.65. Now we will, once we will go and see the options, 15, 30, 45, 60. So this values we know, right? The value of sine 60, sine root 3 by 2. This is 1 by root 2 and this is half. So this values we know. Okay. So we can do a rough calculation here. 1.5. 1.5 can be written as 3 by 2. We can write here already there is one 2. 2.65. This can be written as 1.7 and this can be written as 2.6 or 7, anything. So here if we calculate this, we will get here 5.1, and here 4 into 2.7 into 4. So 8, 2 to 4 is 8, 10.8. Okay, so 10.8. So can we say this is approximately half, right? So the option is 30, because see there is a large difference, half, 1 by root 2, root 3 by 2. So clearly we can see that the option is B. See, what you have to learn from this question is that first you have to read the question slowly. The important things which are given in the question, write this in a rough paper which will be given to you. Okay, so that when you will write the important thing, automatic the formulas which are connecting this parameters will come in your head, will come in your mind. Okay, next, related formulas you have to write. Okay, after that when you are getting the unknown quantity, then just you have to substitute these values and you have to calculate. Now again a smart strategy is going to work out here. You have to just do the calculations in an easy way. Just check the options first. If the variation is large, you can go in approx calculation, and if the variation is small, but the good thing is that you are getting calculator, because now all the exams are in CBT mode. CSIR net is in CBT mode. GATE, TIFR, JEST, all are in CBT mode, so you're going to get a calculator. But if you are appearing for set examination, then you have to calculate. So you should have a habit of calculating, because also if you think that no calculator is there, I can use. Now if this whole value if you are putting in the calculator, it will take time, it will consume more time. Okay, so it's better you get habituated to this type of calculations. Okay, now this was the first question. Now second question, important formulas please write in a separate copy. Okay, important formulas please write in a separate copy. Sums write in a separate copy and theory write in a separate copy. Now second question, consider X-ray diffraction. X-ray diffraction for a crystal, and also check how much time you are taking to solve a problem. This question is, if I am talking about CSIR net, I will say this is a 3.5 marks question. Okay, so please have a track on how much time you are consuming while solving a single problem. Consider X-ray diffraction for a crystal having FCC lattice, which of the following X-ray picks are not allowed. This type of question I have done in the previous lecture, but it was related to BCC, and this is related to FCC. Okay, and also I have told you what is the selection rule for both DCC and FCC in the previous lecture, right? And I told you that this formula is coming due to some calculation regarding structure factor. Okay. So this is consider X-ray diffraction for a crystal having FCC lattice. Which of the following X-ray peaks are not allowed? Okay. So there is a structure factor which is denoted by FHKL. These are F, okay, multiplied with this whole factor. This is for FCC structure. Detailed calculation I will provide you. If you need it, please tell me. I will take a lecture regarding this whole chapter, X-ray diffraction. Okay. Now see, for FCC lattice, the selection rule which you need to remember is the value of HKL that must be even or odd. Okay, all even or all odd. I think in the previous lecture I have told that it must be all even. So there must be some changes in this, all even or all odd. Okay, all even or all odd. So please kindly make this change. Okay. So here now we will check with options. First option is 311, all are odd. 010, 0 is even, so no. 335, all are odd, and 222, all are even. So this is not allowed. In the question they have asked you which picks are not allowed. So our option right is option B. Okay. So this is a very good question for GATE examination. A very standard question for GATE examination and for BARC examination and for TIFR examination. Not TIFR, SET examination. Sorry, not TIFR, SET examination. Okay. This type of question you can also expect in NET examination, but the thing is that SSP comes for 5 marks. It does not come for 3.5 marks in CSIR NET examination. Okay. So this may be a little bit easy for 5 marks, but still you don't know. CSI and NET exam setters can do anything possible. Okay. So our question number 3 is penetration depth. This is regarding the chapter superconductor. Okay. Penetration depth. From this chapter you will get questions which are mainly based on some mathematical formulas. Okay. The penetration depth of mercury, direct formula based question you will get, of mercury at 3.5 K is about 750 Armstrong. What will be the penetration depth at 0 Kelvin if the critical temperature for mercury is 4.2 Kelvin. Okay. So the formula for this is, you need to know the formula, and please remember this formula, that critical temperature lambda is equals to lambda naught, that is sorry, not critical temperature, sorry, penetration depth lambda is equals to penetration depth at 0 Kelvin 1 minus T by Tc whole to the power 4 to the power minus half. Okay, so this is the formula. Now we will substitute the values. We need to find the critical temperature, that we need to find the penetration depth. at 0 Kelvin. Okay, we need to find lambda naught. This is the unknown quantity. So lambda naught is equals to lambda into 1 minus T by Tc whole to the power 4 to the power half. Okay, the lambda value is given 750. 1 minus, this is 3.5, this is 4.2 whole to the power 4 into half. Yes, to the power half. So this value you can use, you can solve by using the calculator, and the value you will get is 414 Armstrong. If you are not getting this value, please comment in the comment box and please let me know. Okay. Now our next question. This is also formula based question, which says that question number 4. The wavelength of photons whose energy is the or is just sufficient to break the Cooper pair in this superconductivity is, and the options are option A 0.4 into 10 to the power 6 Armstrong, option B 0.9 into 10 to the power 6 Armstrong, option C 0.1 into 10 to the power 6 Armstrong, and option D 1.4 into 10 to the power 6 Armstrong. Okay, so this is the question. See, wavelength of the photons whose energy is just sufficient to break the Cooper pair in this superconductivity is. So we need to find the value of lambda. So we know what E is equals to H mu, right? Which can be written as Hc by lambda. So we can write lambda is equals to what? Hc by E. Now here the value of E is given in question. I have not mentioned here, but the value of E is given 30.18 into 10 to the power minus 4 eV. Okay. So now if we substitute the value Hc by E, 30.18 into 10 to the power minus 4, this is in eV. This one thing you need to remember, the value of Hc is 1240 when my E is expressed in eV and lambda is expressed in nanometer. Okay, so here we will substitute this value 1240 30.18 into 10 to the power minus 4. This we will calculate. See, I think in the question, let me check once. Okay, so all is 10 to the power 6. So you have the calculation cannot be approximate. So you will do this in the using the calculator, and you will get the exact value. This one will be 10 to the power 4. This is in nanometer. Okay. So after doing this calculation, you will get 41.08. And if you are not getting this value, please let me know. This you have to remember. These few things is very important. Please write in your note copy. These things are going to save your time. Question is the a voltage of 2.50 microvolt is applied across the Josephson junction, the frequency of alternating current in second inverse. Options are 1.04, 1.90, option C is 1.45 and option D is 1.20. So for this, the mathematical formula which we are going to use it. Please write all the mathematical formula in a formula copy. Okay. So voltage they have given and they need to find the frequency. So frequency of AC current. Questions related to the superconductivity chapter of SSP is mainly formula based. Okay, frequency of AC current in, and this is very important in Josephson junction in all sort of examinations. So please don't leave this chapter. Okay. Frequency of AC current in Josephson junction, the formula is given by 2 EV by H. Almost all the important formulas, sums related to all the important formulas I have told you. Okay. 2 EV by H. So EV we know is what? 1.6 into 10 to the minus 19. V is given in question 2.5 microvolt. So 10 to the minus 6 volt. And H is 6.626 into 10 to the minus 34. This calculation you have to do. 2 into 1.6 into 2.5 by 6.6, 10 to the minus 19 plus 6, or I can say 19 plus 34. Okay. So and 2 into 1.6, 3.2 into 2.5 by 6.6. Okay, let me see the options. Options are close only. So this is, they have, wait a second, the frequency of alternating current. Okay, fine. In second inverse is given. Now let's calculate. This is approximately, I can say, half 2.5 by 2, that is 1.25 into 10 to the power 9, right? This is basically matching with our answer, that is 1.25 is close to 1.20. Okay, so today we will stop here. In the next class again we are going to solve some questions. Okay, we will try to solve some more questions in a single lecture. So keep studying. Thank you so much. If you have any query, any doubt, please let me know. Please share among your friends and do like and subscribe my channel. Thank you.